Hey guys, let's discuss the problem of a mass attached to a string and you're rotating the mass in a vertical circle. Okay, so on the screen, like it's going like this. Okay, in a vertical circle. Okay, so when you rotate it in a vertical circle, right? What is the centripetal force? We're going to look at 2 points. We're going to look at the top and the bottom. So let's draw the circular path over here. Okay. So we're going to look at the top. Let's call this point A. Well, yeah. Well, let's call it A. I'm not going to call it T because we're calling T tension as T. So let's call this point B. Okay. So at the top, now the centripetal force in this case, now the mass is attached to the string, and there is tension along the string, and then the weight of the object is also down, okay, at the top. At the bottom, the tension is still along the string, upward, and weight is down, okay. So in both cases, tension and weight, a combination of these forces is playing the role of centripetal force, right? So the centripetal force is towards the center in both for both the points, okay? But of course, it's going to be a different force. So let's look at the top. At the top, what is the equation? So tension plus weight is equal to your centripetal force. Tension plus weight is equal to the centripetal force, okay? So these are like this tension plus weight is the sum of your radial forces, and that's equal to the centripetal force, okay? And you can further solve this. Now we can plug in weight equals mg, so you get fc minus tension equals fc minus w, so you get mv squared over r minus mg. So that's your tension. Let's call it Ta, okay? That's the tension at the top, okay? Now we can look at the bottom also. So at the bottom, which is our point B, the net force is the centripetal force is tension and weight is down. So tension minus weight is equal to the centripetal force, okay? So sum of the forces towards the center is the centripetal force. So the sum of the force in this at the top is T plus W. They both are in the same direction, and at the bottom is T minus W. Okay, so you get tension equals mg plus mv squared over r, where r is the radius. So this is our tension at point B. Let's call this the velocity. So the velocities. Yeah, so v is the velocity, the magnitude of the velocity. So let's say that the object is moving in this direction. So v is this, and let's say that v is this. Okay, that's the v is the magnitude of velocity. Now these are the tensions at the top and the bottom. Now, when you when you are rotating this object in this vertical circle, if I slow it down at some point, you can see that the string slacks. Slacks means that that the tension goes to 0, right? So I can ask you this question: what is the speed with which I should rotate this so that the tension goes to 0 at the top? Okay, because we have tension at the top and the bottom. So what is the velocity at which tension, the string slacks, in other words, the tension is equal to 0, tension at A equals 0. If that's the case, you can see that you get mv squared over r minus mg equals 0. So if you solve this, you get v equals square root. Mass cancels out of the equation, you get v equals square root of rg. So at this speed, if you rotate the string, if you rotate the string at this speed, the string will slack, okay? In other words, tension will go to 0 at the top. So this was it for the mass attached to a string moving in a vertical circle. If you have any questions, post them in the comments. Thank you for watching.